definitely one worth remembering. Slopes of parallel and perpendicular lines. So you're going to deal with this stuff a lot if you continue with math for the next several years. So in lesson 312, you learn how to label the vertices corners of an image to show how those vertices correspond to the vertices of the original figure. Today you will learn about relationships between an object and its image that will help you predict the image's position. These relationships are described using algebra and are just one example of a connection between the new geometric concepts you're studying and the math you learned in previous courses. So I think it's pretty cool. Coordinate geometry is essentially putting geometric shapes on an algebraic coordinate plane and using algebra in conjunction with geometry to learn more about them, and I think it's kind of cool. So anyways, figure right triangle PAQR was reflected across line L to form triangle P prime Q prime R prime. Describe the relationship of the original triangle and its image to the line of reflection. So there's a lot of things going on here, but essentially, obviously, like we talked about, they sort of go over and down, or diagonally across. But if I connect these lines, you can see it looks like not only are these lines parallel to each other, but it looks like that they're perpendicular to the line of reflection, meaning that we're getting a 90-degree angle. So that's some of what we're going to explore in this lesson, those parallel lines and these perpendicular lines. So says problem 325, you made some observations about a reflection. Slope can help reveal more about such transformations. Begin by graphing the equation y equals 3/4 x minus 4. Use tracing paper to translate the graph of y equals 3/5 x minus 4 up 5 units. Write the equation of the resulting image. What is the relationship between y equals 3/5 x minus 4 and its image? How do their slopes compare? Then we're going to use that same tracing paper and we're going to rotate it 90 degrees counterclockwise about origin. And we're going to write the equation of the result. And we're going to describe that relationship. And it says the original line and the rotated line in part B are perpendicular because they form a 90-degree angle. Where they intersect, look at the slopes of the original line and the rotated line. Make any observations you can. So obviously I'm going to write all this stuff down now and open a coordinate plane and do all this. So kind of bear with me while I set that up. Let's start with this line. So we go up 3/5, up 3/5, and we had a line that looked like this. Uh-oh, not like that. So, what? Why is my life so hard? Okay, let's try that again. Okay, so this is y equals 3/5 x minus 4. So then they said, hey, translate this thing up 5. We don't really need patty paper to do that. If I want to move it up 5, I'll move this point up 5. I'll move this point up 5. And I'll move this point up 5. And you're going to see I've essentially accomplished the same thing. And I mean, obviously I can get the equation of this line. It's clearly y equals 3/5 x minus 4. But by the way, I should probably go back and continue this through. I know that's not perfect, but I do want to be able to continue those lines. So the next thing, so obviously this is y equals 3/5 x plus 1. I don't know what I just said, honestly, but this is y equals 3/5 x plus 1. So we'll jot that down. I think I said I wouldn't, but I'm gonna, because I thought about it and I want it. All right, the next thing it said is rotate this thing about origin. So again, if I rotate this thing about origin, this is up, this is down, this is left, this is right. Well, if I rotate it 90 degrees, this is going to be my new up, which will make this my new down. And if you turn your head, that'll make this my new left, and this my new right. Right? So to get to this point, I went down 4, so I'll go down 4. That's right here. To get to this point, I went right 5 and down 1, so I will go right 5 and down 1. To get to this point, I went right 10 and up 2, so I'll go right 10 and up 2. And you can see I get this line when I rotate it 90 degrees. I kind of missed there, I guess. I don't know. So anyway, it asks us, so the equation of this is going to be kind of a pain, but at least I can get the slope, and that's really one thing to look at is the slope. What's the slope of this one? We can see I'm going down 5 and over 3. And what are the slopes here? The slope here is 3/5, and the slope here is 3/5. So here's what they pointed out to us. They pointed out that these are parallel lines, and what do we notice about parallel lines, about the slope? Obviously the slope is the same. They said that this was a perpendicular slope, meaning it makes a 90-degree angle. Well, what do we notice about the slopes here? How does negative 5/3 compare to 3/5? It looks like it's known as the negative reciprocal, right? The 5/3 becomes 3/5, the negative becomes positive. Or if we go from 3/5, the negative reciprocal becomes negative 5/3. The bottom line is parallel lines have the same slope, right? 3/5 is equal to 3/5 in this case. And this is the perpendicular. Perpendicular lines have negative reciprocals. And that would be like negative 5/3 versus positive 3/5. So that's the relationship that we need to look at, is comparing these slopes between parallel and perpendicular lines and what happens. So let's jump back over here and keep going with this. Yeah, that would have made sense if I didn't do this, but I guess I'm in the process. Am I on 313, I think? Okay, so moving along. Connections with algebra. We did all that, and we made those connections. So 327, investigating slopes. Do you think all perpendicular slopes are related in the way you observed in problem 326? Investigate this idea by drawing 3 different lines with the slope. Use slopes 1, 1/3, negative 3/4. Draw at least one slope triangle for each. Using tracing paper, rotate each 90 degrees counterclockwise or clockwise. I guess we'll do clockwise. And how does each slope rotated compare to the original? Share your surroundings. So obviously 1, 1/3, share your surroundings. Obviously, I'm going to go ahead and pause the video again, draw these quick little lines, and then rotate in a coordinate plane, and we'll see what they look like. To get here, I went right 1. So to get this point, I would go right 1. To get to this point, I went right 2 and up 1. So I will go right 2 and up 1. I think I screwed up that first point, right? I was doing a 180-degree rotation, not a 90, so my mistake. All right, so to get to this point, I went right down 1. So to get here, I will go down. Yeah, I did a 180. Let me pause this. I did a 180-degree rotation instead of a 90, so this is the no up if it's a 90-degree. All right, so down 1, and I would go down 1. To this one, I went right 1, so I would go right 1. This one, I'm going to go right 2 and up 1, so I will go right 2 and up 1, and you can see that those indeed look like perpendicular lines. The next one was they told me to have one with a slope of 1/3. So I'll go here, slope 1/3, up 1/3, up 1/3. So I get a line that looks like this. And if I want to rotate that, here I didn't move, so that won't move. I went right 3 and up 1. So right 3 and up 1. Here we went right 6 and up 2, so right 6 and up 2. I will end up with this line, and you can see again, it looks like I have a nice corner there. So definitely seems to be holding. And then they wanted one with the slope of negative 3/4. So let's go ahead and just go from here. So this point, I'm going to go down 3 and over 4, down 3 and over 4. The problem is I don't have points, which I guess I need. So down 3 and over 4, down 3 and over 4. Okay, so to get to this one, I went up 4, so I have to go up 4. To get this one, I went right 4 and up 1, so I'll go right 4 and up 1. And to get this point, I went right 8 and down 2, so I will go right 8 and down 2. I will connect those dots. And again, oh, yeah, that was brutal. Okay. The world is falling apart. Okay, this time it's going to work. There we go. And you can see I have that perpendicular line. So again, it doesn't matter what the slope is. Negative reciprocals do work. Again, just to kind of talk about that, my slope here is negative 3/4. So my slope here should be positive 4/3. And I go up 4 and over 3, and it is positive 4/3. So you can see I have those negative reciprocals to get the perpendicular slope. I'll pause and go back. So one, it just shows kind of proving it with variables why that's true. So you can see we have this original line, and we did a 90-degree rotation. And it doesn't matter what the slope is, but here the slope, I mean, it matters that we have an A and a B, but it doesn't matter what the actual numbers are because we have a rise of A and a run of B. And this is the slope of the original line. And I hope you could see on this one, right, if we do a 90-degree rotation, it makes sense that our rise now is a negative B and our run is A, right? This would be B, A. I'm going down B and over A. So there you go. There's our negative reciprocals. It says, what if the original line has a slope of 0? Well, then I guess undefined, if you guys remember this is undefined, would be our perpendicular slope there. So I know I went through that problem quickly, but I hope you guys follow what's going on there. It's kind of neat. Up A over B, down B over A, negative reciprocals. All right, so 329, use what you learned about the slopes of parallel and perpendicular lines to write the equation of a line that would meet the criterion below. Write the equation of a line that goes through point 0, negative 3, so this is my y-intercept, and is perpendicular to this slope. Well, if it's perpendicular to the slope negative 2/5, I guess the slope should be positive 5/2. So my equation of this would be y equals 5/2 x minus 3. Makes a lot of sense to me. As a matter of fact, I'll probably throw these in Desmos as soon as I do the last couple just to verify these so you can see them visually. And then it says write the equation of a line that is parallel to this slope, and it goes through this. Well, here's my y-intercept, and my slope, if it's parallel, should be the same. So my equation here would be y equals 3/2 x plus 7. So let me throw these in Desmos just to verify that. They asked us to get the perpendicular line that goes through negative 3. So you can see this goes through negative 3. And you can see it definitely looks like it makes a corner right there. So that definitely looks like 90-degree angles. The second one told us to get a line that was parallel to this one that went through 7. And you can see those do look parallel. I zoom back, they never touch, right? And it does have a y-intercept of 7 there. So that's what that looks like. And finally, it says, suppose the equation for a line is y equals 6/5x minus 10. Line A is parallel to line B, which is perpendicular to line C. If line D is perpendicular to D and E, what is the slope of line E? Justify your conclusion. I love this question. Hopefully you kind of pause this video and figure it out for yourself. But here's the idea. So line A, suppose the equation for line A looks like this. Right, we know it has a slope up 6/5. Line A is parallel to line B, which is perpendicular to line C. Right, need that 90-degree angle. If line D is perpendicular to C and E, so that means E and C are in the same direction, and D is perpendicular to both of them, right? What is the slope of E? Well, it must be perpendicular to 6/5, so it must be negative 5/6 must be the slope. So kind of a fun question on that one, I think.